In this video, I'm going to do a few examples where we're going to calculate some cross products. So I'll just start with the first example here. We want to find A cross B, where A is equal to 1, 5, -3, and B is equal to -6, -2, 4. So the first thing we need to ask ourselves is which definition can we use? And I don't see an angle here, which means we can't really use our geometric definition because that requires the angle between the two vectors. But we do have all of the components, so we can use the component definition. And I'm going to show here an easy way we can visually solve this problem. This is something you can do for all component definition solutions. So I draw this large straight line, this other one, and I put the unit vectors up here. So what I'm going to do is I'm going to write the A vector here and the B vector here. So that would be 1, 5, -3, and -6, -2, 4. Now what I'm going to do is solve for the components. And how I'm going to do this is what you do is if I want to solve for the y component, I cross out that y component and then I multiply across from top left to bottom right, and then I subtract the multiplication of these two. So I'm taking 5 times 4 minus -3 times -2, and that is our I component. And so if you notice, if you look at, say, A cross B is C, the CX component is given by AY BZ minus AZ BY. And that's exactly what this is here. So it's just a nice visual way to show that. And you can easily say, okay, multiply this one by this one, subtract this one by this one. So it's just a visual way to show that. Now what I'm going to do is for this J component, remember the Y component is AZ BX minus AXBZ. So AZ is this one multiplied by this one, but this is backwards to what we just did. We did 1 times 4 minus, or 5 times 4 minus -3 times -2. This one would be -6 times -3 minus 4 times 1. If we want to keep it consistent and make it so we multiply this minus this, we can subtract, and then we can do 1 times 4 minus -3, -6. And that, you could do it the other way around, but it's easier if it's consistent, where you always take these two minus these two, and these two minus these two. So if you want to do that, always remember to put the negative after the J component, or before the J component. Okay, finally, we can solve for the Z component, which is, the formula is AXBY minus AYBX. And so that's, if you cross that out, this is AX times BY. 1 times -2 minus 5 times -6. And that's in the K direction. So then the final answer is you just solve these components. This is 20 minus, these two cancel out, so this positive 6. 20 minus 6 is 14 minus, let's see, 4 minus 18, but that's positive. So it's 14J. And then this will be plus 28K. And that's your final answer. Okay, let's do another problem here. Let's do 2. We want to find A cross B using both definitions. So I'm going to draw out our scenario here. I'm going to draw out a 3-dimensional coordinate system where this is X, Y, and Z. And we've got 2 vectors. So we've got a vector here, and we've got a vector here. This one will be A, this one will be B, and we've got an angle between the two, which is unknown. This point is 2, or this one is 6, 2, 0, and this one is 2, 2, 5, 0. Okay, so now we can solve this, and let's start by doing geometric definition, where A cross B, just to remind ourselves, is A magnitude, B magnitude, sine of theta. Okay, first things first, let's see what we can solve immediately. We can solve for the magnitudes of the 2 vectors because we have all of their components. So let's do that. A, that's just 6 squared plus 2 squared, and that works out to the square root of 40, which is 6.3. So there's our A magnitude. B similarly is 2 squared plus 5 squared. And there's a 0 component here that I could write, but it doesn't make a difference. And that gives us square root of 29, or 5.4. Okay, now there's one more thing we have to find, which is our angle. And so how are we going to do this? We know our components of our vectors, and now we know their magnitudes, but we don't know this theta. And what we can do is we can find the angle of the individual vectors with x. So if we have this angle, I'll call that theta A. This angle here, that'll be theta B. And we can simply find theta by taking the subtraction of theta B and theta A. And that'll give us what's in the middle here. So let's do that. We know for each we know our opposite and adjacent sides, so we can just use tangent, where tangent, I'll write it down here, tangent theta is equal to opposite over adjacent. And so let's start with theta A, we'll just bring our arctangent, do our inverse trig function, and the opposite of A is 2, and then adjacent is 6. So theta A, therefore, is 18.4 degrees. Theta B, similarly, is arctan 5 over 2. And so theta B is 68.2 degrees. Now we have everything we need to find the angle. So theta equals theta B, 68.2 degrees, minus 18.4 degrees. And theta, therefore, is equal to, I have it, 49.8. So that's our angle. Now that can be plugged into here. This can be plugged into, well, I got those backwards, but we can plug everything in there now. So A cross B is equal to 6.3 times 5.4 sine of 49.8 degrees. And this should be the magnitude because we don't have a direction yet. This 2. A cross B magnitude is equal to, that works out to 26. Now, the angle. So, or sorry, the direction. What is the direction here? We have to use our right-hand rule in order to figure this out in this case. So we're taking A cross B, meaning we're measuring the angle from A to B, which is where this arrow comes from. So if I curl my fingers in the direction of A and B, or in the direction of this A to B angle, my thumb is pointing in the Z direction. So that means our resultant vector is this. It's pointing along the Z-axis with a magnitude of 26. And so our final answer for the direction is 26 k hat. And that is our cross product vector. Now, let's do the other method, the component definition. So our vectors A is 6, let's see, you can't see that, 6, 2, 0. So A, let's remind ourselves, 6, 2, 0. And B is equal to 2, 5, 0. Okay, so we have those. Now we can do the same thing as we did in the first problem. We have all our components, so let's write out in this form where we have I, J, K. A is 6, 2, 0. B is 2, 5, 0, which is equal to 2 times 0 minus 0 times 5, I. So that'll, of course, go to 0, minus 6 times 0 minus 0 times 2, J. That'll, of course, also go to 0 because we're multiplying 0 and 0 in both terms. Then the K term, 6 times 5 minus 2 times 2K. That's 30 minus 4. So A cross B is equal to 26K as we would expect, because it's the same two vectors, and so we expect both methods to give us the same answer. Okay, now let's do one more problem. So this one, in this problem, we are given two vectors, A and B, and they have magnitudes. So we're given the magnitudes. A is equal to 2, and B is equal to 5. We're also given that we're given the cross product of the two vectors. So we're not solving for the cross product in this problem, but we're given it, and we're asked to find theta. So we're finding the angle between A and B that gives us this cross product vector. So how do we do this? Well, first thing to notice is angle is a part of this problem. We need to solve for the angle between them. Therefore, it's pretty safe to say we're going to use our geometric definition. So it's always good to just write out your equation. So this is our central equation, the geometric definition. And we want to solve for theta. So a good thing to do first is to solve for your variable, and then we can figure out after that how we want to do the rest of the problem. So multiplying or dividing this down to the other side, you get sine theta equals A cross B divided by the magnitudes of each. And then simply using your inverse sign, you get arc sine of A cross B magnitude. It's important that this is the magnitude over the two individual magnitudes. So this is our final equation. Now we can ask ourselves, what do we need to find in this equation? What do we already know? Well, we know the magnitude of A, we know the magnitude of B, but we don't know the magnitude of the cross product. But we're given the cross product, we're given it in its, we're given the full vector. And so we need its magnitude though. And so in this case, this is simple. We have the vector, so we can just use Pythagorean's theorem to solve for the magnitude. So it's 3 squared plus -7 squared. That is square root of 58, or in decimal form, that is 7.62. Okay, now we have everything we need. We have this, we have this, we have this. So theta is equal to arc sine of 7.62 divided by 2 times 5, or 10. So theta, if you do this, it'll round to 50 degrees. And that is the angle between the two vectors. So those are 3 problems on cross products. Hopefully they were useful. With this method here, if you want to just use the equations, like write out Cx equals ay bz minus b, or az by. If you want to just do this instead of this, that's perfectly fine too. But this is just a way that you'll commonly see as well. But hopefully those problems were useful, and I'll see you in the next video.